It's a lovely pleasure to welcome Jasmine. Jasmine is a recent graduate with a Bachelor of Science in Conservation and Wildlife Biology. Jasmine has an interest in plant pathology, a person of wonderful, wonderful passion to have. She's very interested in invasive species. This is very important given our topic in biosecurity. Jasmine is preparing to do a master's with a plant pathology focus. Today, Jasmine's going to be giving a short talk talking about some real challenges we have with detecting Phytophthora from Xanthorrhoea preissii. Some of the challenges with false negatives, Phytophthora detection, a real challenge that a lot of people here would know about. She's going to talk about improved best practices for sample collection method and some research results. So thank you very much, Jasmine. Perfect.
Hello, everyone. I'm Jasmine. Firstly, I'm going to be completely unprofessional and use notes because this is terrifying.
Speak up.
Cool. All right, I'm too short for this. I'll be presenting the outcomes from a minor study undertaken last year, which investigated the occurrences of false negative Phytophthora detections from Xanthorrhoea preissii samples, and the improved best practice sample collection methods developed from our research results. Oh, I'm sorry.
Okay.
The study was undertaken as a joint project under DBCA during my final year of study at ECU, and I'd like to thank all those who helped or aided with the project. The need for investigation came about from an emerging pattern where samples collected from Xanthorrhoea preissii began representing a questionably high proportion of negative detections, which when retested would return a positive recovery for Phytophthora, hence the false negative. So our aim for this project was to find and remove whatever factor was potentially interfering with the baiting and pathogen recovery process. To determine the most reliable method for sampling Xanthorrhoea preissii, we tested the confidence of different sample types and baiting methods commonly used for pathogen recovery. We sampled recently deceased Xanthorrhoea preissii in known infested areas of the Perth Hills, only choosing specimens interpreted to have dieback-associated deaths. Thank you to dieback interpreter Nathan for his time and hard work searching for and digging up the stinky dead balgas. 3 different samples were collected from each Xanthorrhoea, highlighted. Look it up. We got A is a slack method, sample collecting only roots and soil from the very surface. I've highlighted it in green to indicate the least effort required to dig it up. In the amber, a more robust sample of root and soil from the surface to the root bulb. The slightly deeper root zone is likely to have a more conducive environment for the pathogen. And in the red, an all-inclusive sample of roots, soil, layer of cortex and cambium, and any degraded resin. This is currently the recommended sampling method and is the most labour-intensive as it requires digging up the entire plant. Samples were then baited for Phytophthora following standard methods, except we split each sample bag in 2, one half baited as normal, our initial test, and the other half stored in a cool room as extra or backup sample. This is typically done if samples are exceptionally large. Baiting and culturing samples takes about 2 weeks, resulting in either a positive or negative result. Following initial tests, we then carried out both a double bait and a retest. A double bait reuses the initial sample by draining, drying, and rebaiting, while a retest uses the leftover sample that was stored for 2 weeks during the initial test. Normally, only one or the other method will be used in the event that a sample requires retesting and will depend on the size of available sample, but we tested all 3 of each sample just to check whether this also had any influence on pathogen recovery. Our current sampling recommendations advise to include sections of cambium for larger plants, specifically showcasing Xanthorrhoea as an example. However, our results indicated that samples with any internal material, such as this, were unreliable and most often led to negative Phytophthora detections, even when retested or double baited. We obtained positive recoveries from root and soil only samples from those same plants. Some required retesting, but all resulted in a positive recovery, whether through initial test or retest. We're unsure how, but believe that something found within the internal material interferes with baiting and recovery. So we recommend excluding any internal material. Instead, simply collect moist root and soil material from the surface to beneath the root ball, as this provides the highest confidence for an accurate result. We've learnt that Xanthorrhoeas are not the most reliable indicators, so please opt to sample from a more reliable indicator species if possible. But if Xanthorrhoea preissii is your only option, then collect root and soil only. Thank you.
Thank you, Jasmine. It's a wonderful research. Are you comfortable receiving questions?
Yeah.
Jasmine's lovingly offered to receive some questions, so please, let's get some dialogue. Bruno, we're just going to try and wait for the mic because the audience online can't hear you.
Sure. Great bit of research. Thanks for sharing that. I'm just wondering what your sample size was to come to these conclusions.
It wasn't very large. We only were able to collect 13 Xanthorrhoeas. We only went out for 2 different days. It was just a short project. But even from that, the results said that any of the internal material, it wasn't reliable.
And in what region were the samples taken in? Swan Coastal Plain or the Perth Hills or down south?
So Perth Hills, Kalamunda and Rollestone. Yep.
Thank you.
Another question in the back?
Yeah, thanks.
Oh, yep.
Yeah, thanks for a great presentation. So, as a dieback interpreter, we find that sampling Xanthorrhoeas up on the scarp are a lot more reliable than on the Swan Coastal Plain.
Yep.
And I mean, I don't think there's been any research done into this, but we would speculate that it's because of the free draining soil on the Swan Coastal Plain doesn't allow high concentrations of inoculum around the root ball.
Yeah.
I'm just wondering if that's something that you've considered looking at. Also, in terms of taking some of the cambium layer, sometimes we always take roots and the bulb, but sometimes we do take cambium layer because we find what looks like lesions in the cambium layer.
Yeah.
However, there doesn't seem to be any sort of correlation between those lesions and getting a positive sample result. So yeah, just wondering what sort of, as following up from Bruno, what sort of confidence level you have with these results?
With our samples that we took with internal material, there was more than half of them that didn't provide a positive result. From the plant itself, we obtained positive results from the root only material, so we know that there was Phytophthora there. But then when we baited it, it didn't provide a positive recovery. Does that answer your question?
Yeah.
And this was just in Kalamunda and Rollestone area.
Yeah. So you think that there's something within the cambium layer that is, sort of preventing you from getting an accurate result?
Possibly, yeah. Unfortunately, we didn't have the capacity to look into that further.
Interesting. Thanks.
Yes, great presentation, and sort of raises the issues around sampling for Phytophthora across different environments, etc. And it's one size doesn't fit all. About 25 years ago, I had a student actually look at this problem from the cambium and from the more internal tissues, and we actually leached, ran water over the top of the samples for a number of days and got all the phenolics and other compounds out. And then the recoveries actually increased.
Okay.
And so there's obviously phenolics or other chemicals in those tissues that are very suppressive.
Yeah.
And stop the pathogen coming out in a timely fashion. So that would be something I would look at more closely. again, it was a very small study, but
Yes.
you know, that trend came out quite strongly.
Just want to highlight as well that anybody tuning in online is welcome to put questions in the chat and we'll monitor those. Anybody else? Cool. I'll just make a quick point, everyone. I'm Mia Townsend. I sort of helped come up with this little project. It was a small work placement for Jasmine as just a part of one of her undergrad units. And it was very much designed as a pilot. So, yeah, thinking continued amounts of samples is needed from different soil types and so on to really understand what's going on. There's been some suggestions in the past that maybe there's some kind of phenols or something being released that's suppressing the Phytophthora, but it's not really known. So, do the VHS want to add anything about, is this a continued project or is this nothing that? Nope. Okay, cool. All right, thank you, Jasmine.
Thank you, Jasmine. I'm so honored that Jasmine came today. It's wonderful that we have we seem to have ignited some passion and interest in and demonstrated the fun of studying Phytophthora. And it's wonderful we've got Jasmine involved. And it's even more wonderful that she's seemingly going to be doing continuing this research. I feel this highlights the amazing opportunities there are to do good work and help improve the management of our environments by doing research such as Jasmine's done. And I hope Jasmine can continue her studies and her career throughout her life.